Hello guys and welcome back to my channel. Do you know about NASA's new James Webb Space Telescope which was launched on 24th December 2021? Even if you don't, there is no need to worry about. I am here to tell you. It looks something like this and is currently the world's most powerful space telescope. But what if I told you it could see back in time? Most of you wouldn't probably believe me, but in this video I am going to tell you how. So watch the entire video to know more about this incredible telescope. I am Ridhwan Bhattacharya. Let's get started. Most of you might be wondering, why is it known as James Webb? Here's why. The telescope is named after James Edwin Webb, who was the administrator of NASA from 1961 to 1968. He witnessed each of the critical first few missions of NASA throughout the Mercury and Gemini programs and played an integral role in the Apollo program. So we can say that NASA named their new telescope James Webb to pay tribute to their late administrator. As you might know, before James Webb, Hubble Space Telescope was the most powerful space telescope. So, let's know how James Webb Space Telescope is different from Hubble Space Telescope. Firstly, James Webb will primarily look at the universe in infrared view, while Hubble studies it primarily at optical and ultraviolet wavelength. To understand this, let's know what are infrared rays and how are they useful. Air, as we think, is not completely transparent, especially on a large scale. Celestial bodies generally lie behind huge clouds of dust that absorb light, disabling us to see behind it. Infrared rays are basically a type of radiant energy that are beyond the vision of human beings but can be seen by JWST. All stars and almost all celestial bodies radiate heat. Even human beings and other animals radiate heat. Hence, all these objects can be seen in infrared view. Since dust particle radiates negligible heat, JWST will be able to see beyond that. Thus, will be able to explore many new things. The above is a picture of a human and a giraffe in infrared view. Shown above is a picture of an electromagnetic spectrum. As you can see, infrared rays have a longer wavelength than visible light. In case of any minor obstacles, infrared rays will be able to pass through them because of their low frequency. The above is a picture of the Carina Nebula. On the left side we have a picture in optical view and on the right side we have a picture in the infrared view. Similarly, on the left side we have a picture of the Monkey Head Nebula in optical view and on the right side is the same picture in infrared view. In both cases, in infrared view, we can see more stars that weren't visible before. Thus, the image quality in infrared view is superior to that of optical view. Now, let's talk about the mirror in JWST. The James Webb Space Telescope has a mirror which is 6.5 meters in diameter. It is the largest mirror launched into space till date. It has 18 hexagonal shaped mirrors that together make up the structure of a honeycomb. For a mirror, the larger it is, the more will be the collecting area. Apart from that, its mirror is made up of 24 karat gold because gold is the best reflector of light. As a result, we will be able to get high quality pictures of the universe. James Webb Space Telescope can see a whopping distance of 13 billion light years. 1 light year is defined as the distance traveled by light in 1 year. We know how fast light travels, so we can all imagine it's a pretty long distance. Now comes the most awaited question: how can it see back in time? Light takes some time to reach from one point to the other. Suppose light is traveling a distance of 1 billion light years. Then it will take 1 billion years to reach its destination. Now, if someone is looking at that light from the destination point, what they will see in the light had already happened at the source of light a billion years ago. So essentially, that person is looking in the past. So, theoretically speaking, if some kind of alien is residing in a planet that is 10 million light years away from us and he is inspecting the Earth, he will see the dinosaurs roaming around on Earth that happened 10 million years ago. Because the universe is continuously expanding, the wavelength of the light rays increases and its wavelength stretches towards the wavelength of red, and this phenomena is known as redshift. In this case, the infrared rays come to the rescue. Since the JWST can view both infrared rays as well as the red, yellow and orange, this problem can be avoided. The main aspect that excites people about the JWST is that it will be able to see what happened 0.7 billion years after the Big Bang happened. Studying it, we may find certain secrets that may hold the key to our future survival.